So we want to do.
Totally got it. She explained it. Wait,
No,
Okay,
still
hang
go
on.
over it.
I'm sure there's at least one more person who wants to do 19 through 22.
Yes.
Yes.
Okay, so I want to do 19 through 22 in 9.1. So, June, what was your explanation?
Well, so this zero product rule at the bottom, and then whatever you get, you find the graph that's excluding that number on the graph.
Awesome. Perfect. That is exactly the explanation I would have used in probably a third as many words. Good work.
Yeah, right.
I like this talk. It's dumb. So, yeah, we just look at the bottom, think to ourselves, wait, why am I setting the bottom equal to 0?
0.
Oh, yeah. When am I going to do something I'm not allowed to do, right? When's the bottom going to be 0? That's division by 0. That causes major problems, right? So those values can't give answers, right? And I have to remember that the points on the graph, those things are an input-output pair, right? So what I'm saying when I say the bottom can't be 0 is when the bottom is 0, that input can't have an output, right? So for like 19, I look at this and I think x can't be negative 2. How about for 20? X can't be positive 2. For 22, x can't be negative 4. And for 21, x can't be positive 4. Right? So I just go and find those values. So let's see. This one excludes so it's A. What's the value that x can't be in A? Yeah, that looks like 2, right? The input 2 doesn't give me an output. Why it does this vertical asymptote thing is maybe a thing we'll talk about at the end here. So that one's x can't be 2. Which one does that match?
20.
20. Awesome. I'm matching these the wrong way, apparently. All right, how about this guy?
21.
That's x can't be 4, right? Which looks like 21 to me. How about this guy?
Negative 4.
That looks like I've got a problem at negative 4. And so that's 22. And this dude?
19.
Yeah, that's the other one. 19, right? I don't even need to notice what x can't be on that.
Negative 2. Right.
Okay, so what's the deal with the vertical asymptote thing?
That is where it gets as close.
Okay, there's a fundamental thing you need to know for the vertical asymptote. Right? Here's my idea. I want to know what happens near 2, right? On like number 20. You guys see that? Number 20 has this vertical asymptote at 2. At least it does according to the picture, right? So I'm wondering why the heck is this what's going on? Well, when I think about on number 20, right, that's f of x is 1 over x minus 2. So I think to myself, near 2, right, x minus 2 is when x is almost 2, what's x minus 2?
Almost 0.
Almost 0? Does that make sense? Right, when x is just about 2, subtracting 2 from it will get you just about to 0. Okay, so if x minus 2 is almost 0, then this, right, my 1 over x minus 2 is 1 over really small. You guys see that? Okay, so how many times does a really small number go into 1?
A lot of times.
Lots, right? So 1 over a really small number is really big. Okay, see that? What's really big look like on my picture? Right, this is the output that I'm talking about now. So for inputs near 2, the outputs are really big. Really big looks like high y values. That sort of should explain these ones. Oops, not those ones. There's 20's picture. These ones. Right? Near 2, the outputs are really huge. What's the deal with these ones?
The output is really huge in the negative direction.
Yeah, you guys see that? When I ask how many times does 1 over a really small negative number go in? Or sorry, how many times does a really small negative number go into 1? It goes in a really big negative number of times. You guys see that? Cool this? So really the idea behind the vertical asymptote is this concept. 1 over really small is really big. That's really all there is to it. Cool? Other questions? Good on that?